Hello, this is Britt Caswell with another example video. In this video, I'm going to be covering example 1 from lesson 3-6 in the SavvasRealize Algebra1 textbook. In this video, we are covering what is called finding the line of best fit. So I should probably start by defining that. So what is a line of best fit? Alright, it is a line that closely matches a scatter plot. Alright, so if I have, so say for example I take this data and I put it on a table, which I'm going to sneak down here, I'm going to show you how to create this. But if I have these points on a table, the line of best fit is the line that most closely represents the data that's on that table. So then we have to ask ourselves, what is linear regression? Alright, linear regression is the act of finding the line of best fit. We can also call that line of best fit the trend line. So I'm going to write trend line there so I have more room. Alright, so now we've defined what a line of best fit is. We defined what linear regression is. And I want to show you guys how to find the line of best fit using Desmos. Okay? The reason why I'm showing it to you on Desmos is because the true line of best fit is the line, like I said, that most closely matches this data. So what we do with this data is we will take each of these points and we'll figure out how far away from the line it is. Okay, these red things, these are called residuals. Alright, and the residual is just the distance from the actual value to this trend line, which is the estimated value. Okay, and a computer system will look at all those residuals and figure out which residuals, or which line has the smallest residuals. Okay, so now let me show you how to do this on Desmos. Just unplugging my pen, or else it makes a bunch of noise. Okay, so again, I'm on Desmos.com. So the first thing we need to do is we need to put this table in. So I'm going to hit the plus sign and hit the table button. Now I'm going to type in the x values that are on my table. Now you might have noticed it was trying to predict what I would write next. So just be careful that you're actually typing in what you think you want to type in. So there they are. There are our points. Alright, now you can click this gear up here and you can adjust your x-axis and y-axis if you need to, so that all your points are on there. Mine's already been adjusted. So mine goes from 0 to 20 because, well, 17 is my biggest number, and I wanted a little space. And then it goes from 0 to, I don't know, 275-ish. And that's to give me enough room to have everything on the screen. So now that we have our graph on Desmos here, okay, now we're going to find the line of best fit. So you just go to the next box, and this is what you type in. You hit Y and then 1, and then you need this tilde. Okay, you get this from holding down Shift and hitting the button next to 1. Okay, so this is just the equation in slope-intercept form. The only difference is you have to have these little 1s next to the y and the x. That's because they're supposed to be referencing this x and this y. Some computer programs, some like your book especially, mentions using an A instead of M. It doesn't matter what letter you use there, just recognize it's the one next to X. I like M because we're used to seeing slope-intercept form. So let me show you some of the stuff that's on here. So this R, this is called a correlation coefficient. Alright, it's going to be telling you how close the data is to the table, or to your line. We'll talk about that in another video. So my m value here is, oh, I mistyped into my table. I was wondering why it didn't match my example down there. Double check your work. Make sure that you type things properly. Yeah, that looks good. Okay, anyway. So now this m value, that's what I would write where my slope goes on slope-intercept form. And this b value is where I would write for b. So I'm going to plug my little pen back in, and let's write out our equation now. So we would write y equals mx plus b, right? So our m is 13.5588 times x plus my b value, which is 17.5882. So there's my equation for my line of best fit. Now, as you guys are working on Savvas, they'll probably tell you to round your answers there so that you're not writing the whole numbers, but this one doesn't specifically tell us to. Alright, so here we are. So the next part, they tell us to use linear regression to find the equation for the line of best fit. So I'm just going to actually make my PDF bigger instead of going through Desmos again. So here's the table. Here's where I typed it in on Desmos using that table feature. Now notice your book, see what I was saying about them calling that M and A? I did M on mine because I like having the M, because that's what I'm used to seeing. Okay? And so you can see that line passing through these data points. So if I go to write the equation, I would write y equals my m, which is 0.797135, times x, plus my b value, which is 4.67188. Alright. So there you have it. So that is how we use Desmos to write the line of best fit equation. Until next time.